Hello, calculus fans. Let's talk about vectors. This is going to be a very important thing in this class. We're going to do a lot with vectors. A vector is something that indicates a quantity, like displacement, velocity, torque, or force, and it has to have both magnitude and direction. So when we display a vector, we're going to use a line segment that has a direction associated with it. The length of the arrow will represent what we'll call the magnitude of the vector, and then the direction of the arrow, that tells us what the direction of the vector is. And when we write a vector using a variable, we'll put a little arrow hat over the letter. Now, a lot of times when you read books, they'll use boldface to indicate a vector. That's perfectly fine for a textbook, but that's not so great for handwriting. That's why we use the arrow. Now let's suppose we have an object that moves along a line segment from point A to point B. We're going to call the displacement vector something that has the initial point A and terminal point B. And what we'll write is the vector v is the vector going from A to B. Now let's create a new vector. We're going to call this u, and it'll be the vector that goes from C to D. Here's the picture. So what it looks like is that we've got a couple of different vectors here. Now u looks different than v because it's shifted over to a different spot. But what we're going to say is that they're actually the same vector because it has the same length and direction. We're going to say that u and v are equivalent or equal, and we'll just write u is equal to v as vectors. There is something called a zero vector. It has length 0. It doesn't have any specific direction. You can't even really draw a zero vector, but it's important to have this thing. Now let's talk about combining vectors. Let's say that you've got an object that moves from point A to point B, so that gives you a displacement vector, AB. And now maybe the object will change direction and move from a point B to point C. The total displacement vector is something called the sum of AB and BC. We'll write that AC as a vector is equal to the vector AB plus the vector BC. This is what the picture looks like. So if you start at A and you go to B and then you turn and you go to C, the resulting sum of these two vectors is the vector AC. So you could have just taken a straight line to get there from point A to point C. So the usual way of drawing the sum of two vectors, u and v, is to move v around. And remember, moving the vector around doesn't change the vector so long as you maintain the same length and direction. So you move that vector v around so that the tail of v coincides with the head of u. So we'll make a definition of the sum like this. So if u and v are vectors positioned so that the initial point of v is at the terminal point of u, then the sum u plus v is the vector from the initial point of u to the terminal point of v. The other thing we can do is multiply a vector by a real number. Now we're going to call this real number a scalar, and that distinguishes it from a vector. So a vector has a magnitude and a direction associated with it, whereas a scalar only has a magnitude. It does not have a direction. Now, we would like 2v to just be the vector v plus v. And that has the same direction of v, but it's twice as long. Okay, here's a definition of multiplying a vector by a scalar. Now let's define scalar multiplication. Let's suppose we have a scalar c and a vector v. Then we're going to define the scalar multiple, c times v, as a new vector. Its length is going to be the absolute value of c times the length of v. Its direction is going to be the same as v if c is bigger than 0 and opposite to v if c is less than 0. So if you multiply a vector by a positive number, it keeps the same direction. If you multiply a vector by a negative number, it flips that vector around. If it happens that c is equal to 0 or the vector that we start with is equal to 0, then c times v is going to be the 0 vector. Here's a picture. If you take a vector v and you multiply it by 2, you're just making it 2 times as long, but it still points in the same direction. If you take a vector v and you multiply it by -2, you're making it twice as long, but you're flipping the vector around to be backwards. And we also want to define subtraction. So if we have two vectors, u and v, then u minus v is going to be defined to be u plus -v. All right, let's talk about vector components. Now, it's going to be really useful to have a coordinate system, and we'll treat vectors algebraically. So let's say we take a vector and put its initial point at the origin, and let's say that the terminal point has coordinates of the form a1, a2, or a1, a2, a3. Depending on whether our coordinate system is 2 or 3-dimensional. So if it's 2-dimensional, then just have 2 coordinates. If it's 3-dimensional, you have 3 coordinates. So these coordinates are going to be called the components of our vector A. And we'll write either A is equal to a1, a2, or A is equal to a1, a2, a3. Notice that we're using these special brackets. These are called angle brackets to denote a vector. And it's important to distinguish between a vector a1, a2 and the point a1, a2. They are different sort of objects. Let's keep in mind also that only the direction and length of a vector matters. So we can have different representations of a vector. Let's suppose that we have a representation AB of a vector v, where the point A is x1, y1, z1, and B is x2, y2, z2. Then it must be the case that the vector v is simply x2 minus x1, y2 minus y1, z2 minus z1. Those are the components of the vector v. Okay, that's all for now.